where everything is decentralized, right? The last bullet, developers are needed across infrastructure, apps, and tooling layers. Web3 is such a new environment. You guys are here super early, and this is a great opportunity to use this time to ask any question that you need to start getting familiar with it. We are still super early. There's so many opportunities all around the world about Web3 jobs and more than that. You can be a creator yourself. You can be an inventor yourself. It's a new space, especially on Sui. So many new inventions coming up, so many companies, so many people building. Let's compare the two. Most of you are Web2 developers. You are already probably familiar with these topics, as we say, the pain points, right? Let's start with the Web2 pain points. Why we even want to change this? Why we want to change our approach? Centralized infrastructure. As we said, we have single control points, entities that control the infrastructure. Siloed identity. What does that mean? That means basically that your logins are platform owned. It's not that I have my credentials that I can use to log into X platform and then Z platform, or logins are platform owned, right? Intermediaries in transaction. What I explained, when on the normal Web2 flow, I need to send money to my friend. This is a basic example of a transaction. That's not the only example of a transaction. But of course, I would have to go through the bank, pay the bank man and whatever. So so middleman fees apply there as well. What we mean by opaque backend logic? Anyone want to take a guess? What's this pain point of Web2, right? Opaque backend logic. If you want to take a guess, or I can go forward with this. I think I will. But what we're basically saying is, as all of you know, basically all the Web2 infrastructure is mostly closed source, right? So hidden code, hidden algorithms. You basically are trusting their service that they are not misusing your data, or you are not being mishandled in a sense. So that's not the case with Web3, as we will see. Everything is easily accessed and verifiable by anyone, right? So any contract that has ever been built by Mr. Labs, for example, you can find it on Sui, not just by Mr. Labs, by anyone. And that's the one major differentiator on Web2 versus Web3, right? Okay, on to the next one, vendor lock-in. Basically, that we have closed ecosystems. And the last one, that there is limited creator monetization, meaning that all the profits of an application that you would build, for example, on the Web2 would not be so easily monetized as it would be on Web3. Why? Because, once again, you have full power on Web3. Let's go to Web3 and what we do in order to solve these pain points. We have distributed resilience, right? Decentralized nodes, fault tolerance. You will understand what this means in the following concepts if you are not already familiar with this. Self-sovereign wallets. You have your own wallet, you have your own identity, right? It's not that your identity lives under a platform. Your identity is just a wallet that you use to interact with a chain, and anything that exists on this chain's ecosystem, you will be able to access. No platform-owned identities. Smart contracts, peer-to-peer finance. So here on Web3, you only trust the code, which code you will be able to see, right? Open data, transparent, auditable contracts. We'll see how you can actually view everybody's contract, right? Open data composability, on-chain royalties, NFTs, and stuff like that. This is basically NFTs that you have direct ownership to, and any concept that any asset on chain is basically something that you own, not like imagine a game like CS:GO or whatever. I don't want to name drop, but for example, you have a skin to a gun on the game. This skin to this gun to this game is only specific to this game, right? You don't actually own this asset. You own this asset through this game. If the company were to ban your account or whatever, you lose this item. This is one concept where NFTs do not act like that. You own the object itself, the skin, whatever this is, and theoretically you could move across ecosystems and games with this NFT. Any questions so far? Should we move on? Cool. So we said some stuff about distributed ledgers and blockchain and stuff like that. But what is it exactly, right? Many people, when they hear blockchain, they often think only of crypto, right? But the concept is so much broader than this. Think of the blockchain as like a shared database, right? A shared database that everyone can verify, but in order to change it, you have to take some different approach. We will see what this is. So, a database that basically everyone can verify. So, imagine that why we name it a blockchain. Imagine a block is basically a batch of transactions. And what we mean by transactions is basically any interaction that you have with the chain that is not a read operation, because you can read everything from the chain without having to create the transactions. Read operations are free. But if you want to do something to the network, store something, transact with somebody, send money to your friend or whatever, this would be considered a transaction. So many batched transactions create a block, right? And one block is linked to the next one, right? So this is in order to create sequencing. So this is basically what makes a blockchain, right? Blocks linked to the previous one, forming a chain. So because it's decentralized, there's no actually a single authority controlling the blockchain. Nobody is actually controlling this. But the trust is just is built through the code that the validators run. And what are the validators? We'll see shortly. Let's go basically on the main differences on architecture-wise on Web 2 versus Web 3. I think this is important for you guys to understand, since most of you come from Web 2 backgrounds. Basically, on the left, we see on Web 2 that basically everything is run through a central server, right? So data, identities, and permissions are controlled by basically a company, right? Give me a second, excuse me. Cool, so of course we know that Web 2 is reliable, right? It's efficient. This is how the internet has come to be to today, right? But as efficient as this is, this creates bottlenecks, right? And privacy concerns. As we said, you have to trust a certain company with your data, right? So Web3 replaces this centralized model with a decentralized approach where users interact through wallets and smart contracts, which we will see what smart contracts actually are, on a shared network. Imagine on a shared database, as we said, a shared verifiable database. So all their data and the ownership is verified through this, let's say, shared database, and not inside a corporate closed database that nobody can verify, right? So it's an entire mind shift. It's basically that you are 100% certain of the things that you own, if of course you are they are under your wallet, let's say. Have you ever guys heard of this term, proof of work? Proof of work, yeah. So we are going to be, let's say, looking into the ways how this system that we're explaining, the network, the blockchain, how it actually operates, because it's not just magic, right? It has to run on certain technologies, certain algorithms, and make sense. So early blockchains like Bitcoin started to secure their network using proof of work. And in this model, for those who are not familiar with proof of work, it's basically that the miners, you know what the miners are? The miners are basically, let's say, programs that compete to solve cryptographic puzzles, right? And whoever solves it first would be able to add a block on the chain and get rewarded for that with Bitcoin, for example, if you are to have a Bitcoin miner. So they spend huge amounts of energy, GPU, CPU, or whatever, in order to compute and solve some really complex algorithms that would allow them to add something on the block. So a new block on the blockchain. For this energy usage, of course, they have to pay. This is how the miners are incentivized to not lie, to not try to create false or scam blocks. Why? Because you're already committing by spending so much energy to computing these algorithms that if you were to be cut out of the network and say that the other validators say that your block is a scam block, so you are cut out, that means that you have already spent so much money in energy that you would not do that. So you are incentivized by paying with energy. Of course, it's secure, but it's really highly power intensive and so much slower. So all of the modern chains after Bitcoin are using proof of stake. Have you ever heard of proof of stake? Anybody? Some folks, yeah. Basically, the main difference with proof of stake is that instead of energy usage, the validators here are chosen based on the amount of the native blockchain token they have staked. And what we mean by stake is basically that you have locked a certain amount of X said coin, in a sense that I say, hey, I'm Dio, I'm alongside a few other folks, I am a validator, I want you to trust me that I will try to preserve truth for this network, and for you to trust me, I will bet my house that I will always tell you the truth. If the other entire team at any point in the future says, come on, Dio, you are lying here, this is false, but okay, we do not trust Dio anymore, take his house away. This is basically what schlossing is. The network and the code that is run in any validator can prove that if a validator is trying to act maliciously, so not trying to preserve the truth of the network, they can be slashed. So part of their stake, what they've given to the network, can be taken away. So you imagine that if you are a validator and you have taken a huge amount of Sui, for example, you wouldn't want to lie, because you will actually lose your money, and you don't want that. You want to be part of the network of truth, and you are betting something to say, look, I'm gonna be truthful. Any questions regarding proof of work or proof of stake? Yeah?
That guy will try to solve the non-problem, right? Only
Ye-
one guy.
Exactly. Basically, based on your stake, that's why stake matters, like, right? So, and everybody can actually support a validator. Each of us can support a validator by staking our own coin into this validator, and by the more stake a validator has, this makes into like an algorithm that chooses who of the validators will be actually the one who is responsible for solving this quiz and then get rewarded, of course. It doesn't mean that who has the biggest stake is the one who gets the opportunity to solve the quiz and get rewarded, but staking plays a factor into this algorithm. And the validators at any network are not like infinite. It's a certain amount of validators depending on the network. On Sui, it's 122 if I'm not mistaken. But it's not that only these 122 validators are controlling the truth. I want you to think of it as a democratic concept, because each of us, let's say, we can see who these 122 validators are, for example. Of course, anyone can become a new validator. If you have the certain amount of Sui to stake, right? You can become a validator. But let's say we don't have that huge amount of Sui, but we are trusting a certain validator. Me, as Dio, I can stake my Sui on a certain validator, so I increase their power because I trust them, and so wherever they actually get rewarded, I get some reward myself, because I'm saying I put my trust in you, I stake my Sui to you, you are able to be chosen more times to run quizzes, so I am rewarded back. So this is the entire concept of staking. Good?
Yeah, like do they solve the same problem as proof of work? Like I know that proof of work, a lot of people try to compete, like the fastest one solve the problem, get the reward. Like they try to find a non-number. Is it the same thing with proof of stake? They also find a non-number, right?
I'm not entirely sure what's the algorithm that is being solved, if that's your question.
Okay.
But I can follow up with you. This basically is really detailed stuff on what the algorithm being solved is. But I know that is a really intense mathematical problem. Let's say. Not exactly sure if it's the same as proof of work. You have to solve something, of course.
Okay, thank you.
No worries. Any other questions before we move on? So, let's look at the evolution of blockchain in general. Starting in 2008 with Bitcoin. As all of you know, Satoshi Nakamoto with a paper that introduced the idea of money without banks, basically, right? Cutting the middleman. And basically a world built on trust through the people and not through centralized entities. One huge problem of Bitcoin, however, other than the proof of work and how slow it is, basically, is the fact that we are just stopping at monetary interactions, right? So, Ethereum later on came to solve with this problem with smart contracts. We will see in a bit what smart contracts are, but basically is you now have the ability, after Ethereum was introduced in 2015, to create code that is verifiable on chain, and that means you can now create businesses that utilize blockchain, not just monetary exchanges between A and B. Afterwards, we see that we have many more that try to solve their own problems, like Cardano, Avalanche, Polkadot, Solana, which came the first one to really tackle on speed, right? Because since we're thinking about building real applications on top of Web3, speed is one of the main concerns, right? No one wants to utilize an application that take ages to get to work. Afterwards, there was Aptos and Sui, right? And we're here today to talk all about Sui. Sui's main difference to the other networks is basically comes from its object-centric model, so that everything on Sui is basically an object, right? That is owned or shared or we'll see what. So you have direct ownership of your assets. We'll see how that plays part and how it's different from other blockchains. Here is a table of some metrics that is basically like comparing some of the most well-known blockchains. We see the transactions per second, the language used to create the smart contracts, and their unique trait. I want to basically focus on Sui, of course. Our consensus algorithm is called Mysticeti. We see that we have achieved upwards to 120,000 transactions per second. You see that these numbers are so far so much bigger than the other networks, even compared to Solana, which is considered a really fast blockchain. And our programming language is Move. You see that our unique trait is the object-centric model. We'll dive really deep into what we mean by that. But what I want to basically discuss here and what's important to talk about is what's so different with Sui? Why such a big number? Why so many transactions per second? We'll see that with the consensus that exists on Sui, basically, there are some paths that do not require basically the entire network to go through consensus. In that case, we have what we call the fast path of a transaction that can be finalized instantly. So this is why we have these huge numbers. And it's actually even more than that. In research environments, we've gone upwards to close to 300,000 transactions per second. So you imagine that this is why everybody calls Sui the blockchain of the future, because we are actually have solved this issue, and we're even trying to improve further on this. So any application can be on top of Sui and be actually usable, not have a delay and a bad user experience. Smart contracts. Who wants to take the microphone and maybe try to tell us what smart contracts are? I want to involve you guys so I don't bore you. I don't want you to just listen to me. Who wants to help us understand what smart contracts are? You want to take this?
Yeah.
Let's do it, yeah.
Smart contract basically is just a computer program. That's it. But it will run on a certain condition. When it meets some certain conditions, it will automatically run the code. And the thing that distinct the smart contract than all the normal codes is that it's run on blockchains. Like once you deploy the smart contract, you are not able to edit it, and everyone can view the smart contract code.
Absolutely, thank you very much. This is the correct answer, yes. It's basically a piece of code that runs on the blockchain, right? Everyone can verify it. You cannot modify it. Of course, you can upgrade it, and we'll see how, but upgrading a smart contract means that basically you are creating a different entity of this smart contract. So a user that is interacting with a certain smart contract cannot be, let's say, surprised that something changed. This is why we put trust as number one. You know that you're interacting with a certain smart contract that does certain stuff after some conditions are met, and it basically lives on every validator, right? What you see here is basically what we are trying to depict by the network of validators. Imagine this being 120 something, like on Sui, which are basically the validators, which are servers who have the consensus and create our truth. Let's say our blockchain, basically, our validators. And our smart contracts live on every validator. So we know that I have created and published a smart contract on Sui, right? So every validator knows of my smart contract. So that means that all nodes verify and reach the same outcome, the same result. Of course, as our friend said, the smart contracts cannot be changed. Real world use cases. Decentralized finance, which is basically the most popular one, right? Interacting with the network and having financial benefit through any strategies that you have this on a decentralized matter and not through a bank or something. NFTs, you have ownership of digital assets, real ownership. They live on your wallet, basically. You can see them on your wallet. Gaming, tokenized economies, in-game assets, and many, many more. Like the example that we said, a skin on a game, or a gun, or whatever, could be an NFT itself that you own directly. Any identity credentials can be stored on chain for like governments who would want to utilize a blockchain, and the fact that it's transparent. Imagine, as we said, if the concept of the blockchain is still blurry to you, imagine like a transparent database that anyone can work with. Imagine how that can assist governments, for example, and many, many, many more. So it's not all good about Web3, right? There are some limitations and open problems, and that's why we need brilliant minds like you to help us solve these problems. Like, one problem, energy usage. As we said, especially with proof of work, proof of stake, not so much, but still. Regulation uncertainty, right? Because in order to interact with a blockchain, you do not actually KYC, you do not give your credentials, let's say. You just create a wallet. Anyone can be behind that wallet. So some, let's say, not so legal stuff can happen on blockchains because of this thing, because you actually do not know who is behind any wallet. So there are some regulation uncertainty and some reasons why governments are a bit hesitant into introducing blockchains as a technology in their stacks, right? UX friction, wallets and keys. In case you lose your keys to your wallet, you're basically lost access to all your assets, all your tokens or whatever. So you have to be so much careful with that. There is no thing as like forgot password or get my account back on wallet, because as we said, you are not, this is not linked to an identity in a sense. So if you lose your stuff, you're out. You have to create a new wallet. Scalability trade-offs, security vulnerabilities, and many, many more. So many problems, but they are being solved by so many brilliant minds as we speak. Some key takeaways: what the blockchain is, decentralized programmable trust layer, different consensus models fit different, have different trade-offs, as we previously mentioned, with proof of work, proof of stake. a space full of opportunity. Thank you. This was like the first introduction to blockchain in general. Uh, Many of you who are already familiar with what blockchain and Web3 are probably so tired and bored right now. I apologize, but we needed to start from zero, right? Any questions now that we finished this, basically this introductory concepts? Are you familiar with what the blockchain is? Where were you already? Should I move faster? What do you think? Give me some feedback. If you think we should move a bit faster, if you think you're already familiar with the stuff, raise your hand. If you think we're going just right, keep your hand down. Okay, not many of you think we should move a bit faster. I think we'll stick to this pace. Um, if those of you guys who are really familiar with that stuff, feel free to go on the repo that I shared on the chat, and maybe you can jump along, right? We can do that. Okay, great. So let's continue with a short introductory on the Sui stack. Give me a few moments to load up the next slides. One, two, one, two. We are back. Now, let's start talking about the Sui ecosystem itself, right? The Sui ecosystem, just an overview. We see, I want you to make a noise if you know the terms that I will be talking about. Walrus. Yeah, let's go a clap or something like that. Slush. What about NS? Name service. Okay, okay, a few folks. Do you know Seal? Have you heard of Seal? Seal, yes. What about Enoki? Enoki, not so many. We'll see what Enoki is actually. Dipuk, a few, and Nautilus. I know that our friend here has worked with, a few folks have worked with Nautilus already. Seal and Nautilus are quite new, so I think you guys are up to date on the latest stuff that we have. Great. Everybody has attended these workshops that we're talking about? Some of them. Great, great. What were these workshops about?
We talk about the latest Sui stack, and also like help everyone to build something on this start. Like the previous one, we have everyone to make their own decks by using the Sui stack. Yeah, and then this one, I really appreciate him. That he, when I first met him, he don't know about how to code on Sui, but after several workshop, they can now do like
make their own make his own decks. Yeah.
That's really good to hear.
Yeah.
After a few workshops, you're already familiar with the Sui stack and write and move, right? That's cool. That's so cool.
So in class, I also call him a good student.
Good to meet you, good student. Okay, so we'll get through this quick. As I understand, most of you have already been familiar with this, all these entities due to workshops, but we'll just introduce each one of these. So, walrus. Let me go on the other side. Walrus, right? A storage network, decentralized storage network, not a blockchain, but a storage network for, let's say, any multimedia that you would be able to store. So many more benefits than the other alternatives. If you would like to dive deep into Walrus, considering time, we won't do that today or at this workshop in general, but feel free to reach out to me or any of my fellow ambassadors or any of my colleagues. We can guide you to further Walrus documentation and how you can actually utilize Walrus alongside Sui to any dApp you're building or any application that you have in mind. SuiNS, basically mapping your address to a beautiful, a more human readable nickname. That's basically what SuiNS is. You might be familiar with ENS from Ethereum or whatever. You are basically, this is what this NS is basically trying to do, is one step further in avoiding the friction of Web3, because interacting with someone on Web3 means that you will have to provide their big, long, ugly address that you cannot remember actually. So mapping that into a SuiNS, that would be as simple as I open my Slash wallet, I want to send 10 Sui to William, and I'm just like send 10 Sui to @william.sui. So basically as simple as that. Slash, our wallet, or basically our Sui wallet. I hope you guys already have created a Sui wallet. You have Slash or whatever you prefer, because we will actually be interacting with contracts and the stuff that we deploy on the network through our wallets. Enoki, what this allows us? Basically, a gas station as a service. We'll see what it means later on. Don't get scared by terms like that. Invisible wallet. What does this mean? Basically that anytime you interact with any application, any smart contract, let's say, on chain, that would mean that you actually need to approve of the transaction, sign the transaction. What that means is basically that a pop-up or something would pop up on your screen. You will need to provide your credentials and then sign the transaction. This creates some friction. Of course, this is a necessary step for you to say that I want to interact with this chain. Nothing can happen automatically. This is not like Web 2, because you are approving of the transaction, whatever that could be, by explicitly saying approve. But you imagine that you're playing a game and every time you press the right button or the left, or you move, you are prompted to sign a transaction. This will not work. So there are many applications in the real world and many scenarios where approving every transaction and having this friction of pop-up wallets and stuff like that really hurts the user experience. So through Enoki, there is this thing called ZK login. Familiar with that? What ZK login is? Which is basically creates this concept of an invisible wallet and signing that happens under the hood. We'll see more on that later on, right? Deepbook, do you want to take this? Somebody? I feel that we talked a bit about Deepbook and how you can build a decentralized central limit ordered book, your own DEX, let's say, with Deepbook. It also, of course, has the Deep token, which can be used to clubs. Seal works like peanut butter and jelly with Walrus. Basically, encryption for your data that will live on Sui or Walrus, for example. Because, as you know, that any data stored on the chain, as we said, it's public, basically. That is the case for Walrus as well. So theoretically, I would upload an image to Walrus, because why would I even want to upload an image on Walrus? I don't want to upload it on AWS, for example, because I either don't trust it or I want to be the only one who owns this image. So I upload it to Walrus. So if I do not encrypt it, that means that with this blob ID, as we call it on Walrus, anybody, if they were to come up to my blob ID and they were to fetch it, they would be able to see my image. That's not a good scenario for sensitive data or for personal data. Seal comes to solve this issue with basically encryption, built-in encryption, with access policies that are verified on-chain. That means, for example, that I have a set an access policy that only me and my brother will be able to decrypt these images or whatever asset I have stored on Sui and Walrus, right? So encryption on top of blockchain. This is what Seal gave us. That's quite a new product already. We have a question? Yeah.
So yeah, I have a question that do we have to host our own server to run the shield, or we just interact with it?
There are already some key servers for that,
Okay.
but you are given the functionality to also extend it by having your own key servers, but you do not have to do it by design. If you want, you can extend the functionality by providing your own key servers.
Okay, I got it.
Any other question? Should we move forward? Yes.
I have a question about Enoki new methods. Actually, I have used Enoki for my project recently, actually a day ago, and I can see that when I use Enoki, I need to backend handle the request. Yes. Right.
Yes, you need a backend in order to actually store your API key for the Enoki client. Yeah.
And I wonder something about who spawn who will pay the gas. I mean sponsor gas. Any lesson
Who is responsible to pay for the gas, you mean? You can actually set and get basically this is just a quick parenthesis for everybody who is not familiar with Enoki. Just a quick recap so you have some context of what we're talking about. As we said, this is gas station as a service. Basically with Enoki, you can, excuse me for 2 minutes, I give more context before I answer your question, so everybody follows. A step back. In order to interact with a chain, for every transaction, you have to pay gas. In case you're not familiar with this concept, it's basically that I'm saying that I want to send money to William. I sent him 1 Sui, but from my account, there will be just a tiny fraction of Sui also being decreased, which will be the transaction gas. What is this transaction gas? It's basically what will be given to the validators in order to run this consensus mechanism that we said, in order to add this transaction to the chain forever, right? So I have to pay them a tiny fraction amount, which is called the gas, like the gas on the vehicle, for this to all work. So this also would potentially create some friction to the users that are not familiar with the concept of gas, that you have to pay some certain amount in order to interact with the network. So Enoki solves this issue by introducing gas station as a service, which means I am a company, for example, I am a developer that I want to build a product, a game or whatever, and I say, I am responsible to sponsor the gas of every transaction that happens on my game, on my smart contracts, so that the user does not have to pay the gas, right? So that means by design, the one who is invoking a transaction is the one who pays the gas. But if you utilize Enoki, you can sponsor the transaction gas. So following up to your question now, sorry to take so long, it's basically that through the Enoki portal, you can have different, let's say, tiers and how you manage your gas station itself, so that you, as the, let's say, the person behind the application, will be able to set who the gas payer is. So the whole concept of utilizing Enoki, for that matter, is to have sponsored transactions. So you will be the one paying. Did I answer the question?
Yeah. When I use Enoki to who log in with UK login, I can see that Enoki will sponsor any transaction. So any limitation of the amount that they.
Yeah. Using ZK login or using sponsored transactions are actually two different things. You can have ZK login addresses, but still have the user pay the transaction. So if you want to actually go through the sponsored transactions flow, that means that you have to purchase a certain bundle for gas that you will pay, or have a concept of pay as you go. I'm not entirely sure what the cost for that is, but you can find that through the Enoki portal, basically. That you say that I want to pay for these transactions that happen from any user.
I get it.
Great.
Thank you.
No worries. Last but not least, Nautilus. So, just a quick recap on smart contracts. Smart contracts, what smart contracts are, is basically, as we said, code that runs on chain. That does not mean that smart contracts are the best fit for really high intensive computations and algorithms and stuff like that. Think of it, because of course, why is that the case? Because any transaction on chain requires gas. So the more complex it is, the more expensive it is. So the harder it would be for many users to use your application and etc. So what does that mean is that sometimes we have to move some logic off-chain, some computations and stuff like that. So that's how Nautilus comes into play. Because we still need, for example, to run a really complex algorithm for our game on a backend that is not a smart contract, but we need to make sure that we are able to verify that this was still done the right way, and then and done in a trusted execution environment. If any of you needs to take a look further into Nautilus, please let me know and I will share further documentation. But for the matter of this bootcamp, all you need to know is basically that we have more complex logic on a trusted execution environment, but we still need to verify on-chain that everything was done the right way. We can utilize Nautilus for that. Yes.
I have a question about the slush wallet. In the future, do Sui will Sui support the address that which is set up by Google account to able to publish the contract on chain?
I didn't get the question. Can you please repeat? Or can you say it in Vietnamese and William will help me?
Ok, ok, vậy anh đang nói cho em trong tương lai thì Su có liệu rằng có hỗ trợ việc hỗ trợ cho những cái tài khoản Google không? Anh nói là trong tương lai liệu rằng Su có thể hỗ trợ những tài khoản, những địa chỉ được tạo bởi tài khoản Google mà là tài khoản mạng xã hội khác trên trên Slug Wallet để publish cái smart contract lên on-chain được không?
Okay, so his question is, will Slug Wallet in the future like support the like ZK? They use the ZK login. They log in with Google, Facebook, or the other social, and then publish their smart contract and publish it into the Sui network. Is it like available to do now or in the future?
Basically publish through the Slash wallet.
Yeah, that's right.
I think it is not. I am not entirely sure, but I for sure know that the team of Slash is extending the functionality of Slash so much in this upcoming year. So this could be one of the things. I could follow up with you and follow up on this question. Basically, publish, but we will see that there is so much easier way to do that through the CLI, right? But I'm not entirely sure if you will be able to do that in the future. Last thing, I want to involve you guys before we also finish with this one. I want hands for those who want to grab a word from here and explain what it is. This is basically terminology that we will be using for this entire week. So feel free to raise your hand, grab a word, and explain what it is. Any of these. Take a moment to look at them. No rush. Take your time and see these. Who wants to tell us to remind us what gas is? What is gas? That's right. The small fraction of the token that you pay for the transaction to go through. That is actually giving as a reward to the validators. What about the three words that we see on the first line? DevNet, testnet, mainnet. So, can you, can you follow up again what you said? You said the environments. Basically, the different environment states of a network. And I heard a question about what's the difference between DevNet and testnet. As all of you know, basically, or if you do not know, let's say the production environment of any blockchain is mainnet, right? So any contract that you deploy on mainnet, any tokens that you have on mainnet, that's basically the real money, or that's basically the real application, the one that lives on mainnet. Testnet is like a testbed that we use before we want to actually publish our smart contracts on mainnet. Of course, we need to test. We need to be sure. We need to be exactly sure that testnet is exactly like mainnet, right? So there's no difference inside what the code of the validators that is being run, so that we are certain that when we upload our testnet contract into mainnet afterwards, we have the same results. And why do I have devnet and testnet? Basically, DevNet is the first step after a new, let's say, feature is introduced into the network. That would be a new protocol like Seal or Nautilus. Everything that's new, either from Misten Labs as the main contributor to Sui, or from any other developer through just a pull request to the Sui repository. For example, you could have created an extension to the Sui network. So this would mean that the validators will need to run new code, updated code. The first network state that gets these updates is DevNet. So if you want to experiment, let's say, with a new feature coming up, for example, Nautilus, it first came to DevNet. So if you wanted to work with Nautilus on an early stage and experiment with it and get prepared for your application for when it comes to mainnet, you would be working on DevNet. Afterwards, it would go to testnet on a more stable version, and afterwards to mainnet on a final version. And another difference between the two, DevNet and testnet, because those two, of course, are not real production environments, is that DevNet gets wiped quite often. That means that the state of the network is reset every week, if I'm not mistaken. But for testnet, that's not the case. It's like close to a year. So what does that mean? That means that if I have created, I have published a smart contract for the bootcamps, right? And we will use these smart contracts here. I used it in Nigeria 1 month ago. We used it in Turkey 2 months ago. Because it's published on testnet, we can do that. If it was published on DevNet, we would need to actually republish all the time, every week. So it depends. If you want to test something for a longer period of time, it would be best if you use testnet. That's the main difference between the two.
Có ai cần dịch lại tiếng Việt không? Cần dịch để giải lại tiếng Việt một lần nữa không?
Everything clear so far? Full node. Anyone who knows what a full node is? Those who have some Web3 knowledge who would want to take this on? Any takers before I explain? You want to tell us about full node and staking? Please do so. Can you get the... Sorry? Programmable transaction block. Yeah, please do that. Thank you.
I don't know full node.
Okay, tell us about the full node. What the full node is.
I understand myself staking and transaction.
Oh, whatever. Which one would you?
Some about. I'm not sure.
Yeah. Give it a shot. I will add on your answer. No worries. This is not a test. Of course, we have not dived deep into this yet. This is not a test. This is not a quiz. Just if you know already.
Some wonder you tell me about them.
Oh, I thought you wanted to answer. You want me to talk about them. Anyone, before I tell you the answer, does anyone want to try? Or should I start?
I think we want to hear about full nodes first.
Okay, let's start from the full node. Basically, think of the full node as like the server that would be your first, as a user that wants to interact with the network, with the validators themselves. You don't actually do that exactly directly to the validators. You do that through a full node. Imagine this as, if we were talking in a Web 2 scenario, as the API that allows you to talk to the network. So that's the full node. The full node does not actually, the full node server that you are utilizing to talk to the network does not actually take part in the validation process, but allows you to build, let's say, a path to communicate with the network. It has the latest image of the network. So this is basically your gateway to access the validators.
So if we have a full node, is there any not full node? It's just a line node. So we have this.
Can you say that again? Excuse me.
It's not full node. It's line node.
It's light node.
Yeah, yeah.
I'm not entirely familiar with that term. Can you explain further?
It's not the functional of the full node. It's just line node and stacking another function. It's just function line or stacking. It's not a full node. It's a line node. Just we. I think Sui not have. So we just have the full node. It's another type of node on Sui.
Not?
There's another type of node on Sui.
Oh, no, it's not.
Yeah, yeah. It's just a full node.
Yes.
Yeah, yeah.
Yes. So about staking, we briefly talked about staking before. It's basically where you lock, in a sense, you lock your tokens. You put your trust into a certain validator, for example. You support their voting power, let's say, and you get rewarded back for your trust. You get like a small cut of the benefits that they acquire by the gas fees. So the entire flow is the user interacts with the network, they pay gas fees, the validators collect these gas fees, and they distribute them to those who have staked, for example, Sui, to them. This is the concept of staking. You still own these tokens that you have staked. It's not that you do not own them, but you can utilize them, but you have to unlock them, because if they're staked, they are locked. And we also talked about, we have questions about the programmable transaction block. So that's something that's native to Sui, and how the object-centric model allows us to think of these on more of an object-oriented programming language approach, and jumping into programmable transaction blocks. Imagine that on Sui, you can actually batch upwards to 1,024 transactions, all in the same block, and sign and execute this block once. So basically pay gas fees once. How is this allowed on Sui? Basically, it's because of, as we will find out, that everything is basically an object. Every asset that lives on chain is basically an object. That means that you can combine the objects to create a sequential block that makes sense to be only executed once. I'll give you an example. I have a smart contract that creates a hero, creates weapons, and equips the weapon to the user, right, to the hero. So that means I would have 3 transactions. First, create the hero, that's one transaction. The next one would be create the weapon, that's the second transaction. The third would be equip the weapon to the hero. So 3 transactions. I can program a block, we'll see how we will do that. We'll do that on day 3 if I'm not mistaken. And I can sequentially create these transactions, one after the other, to be signed and execute only once. Of course, the 1,024 number is not exact. It's upwards to that. Of course, it differs based on the payload of the transactions. Those transactions that I just mentioned have minimal payload, so they would fit upwards to the 1,000th mark, right? But one thing to have in mind with these programmable transaction blocks is that it has one really huge benefit, the fact that you are able to program your block in a sense that you think makes sense sequentially, as we said, because, for example, in Ethereum, these three would have to be three separate transactions. So you would have to pay gas and wait for network finality 3 different times. But on Sui, only once, due to the object-centric model, and we'll see further. But you have to be sure that your programmable transaction block makes sense, because if any of these transactions at any point in the sequence fails, that would mean that the entire programmable transaction block fails. Everything has to check and go green in order for the transaction at the end to be executed. So if I say, for example, that I create the hero, then I create the weapon, then I transfer the weapon to William, and then I try to equip the weapon to the hero, that would fail. Why would that fail? Because on step 3, I transferred the ownership of the weapon. So that means that when the network reaches the 4th step and it tries to equip this weapon to this hero, it will not be able to do that because I do not own this object any longer. So that means that the entire block would fail. So you have to make sure while constructing your PTBs that your flow sequentially makes sense. Is that clear? Great. We briefly talked about validators, different flavors of wallets. I think if there are no further questions, we are free to move into the next topic. Any questions? We are all good? All good. Great. I think we'll go on for like 30 minutes more before we have a break for lunch. At around 1:15, something like that, we'll have a break for lunch. But before that, we'll jump into the next topic. Please give me a minute or so to load up the next slides. Of course, feel free to grab anything you'd like, to grab a bite, grab a drink at the meantime while I get prepared for the next topic. Should we start with the introduction to Sui and Move, right? Move, the programming language that we use in order to create the smart contracts that we deploy on Sui. I'll give you a minute or so to get prepared and take your seats. While we're waiting for all the folks to get hydrated, any questions on the things that we previously mentioned? Is the concept of blockchain clear to everybody? Great, nice. Also, if of course, feel free at any time to talk to our ambassadors, right? If you want to speak to them in Vietnamese, for example, no worries. I'll try to learn Vietnamese by tomorrow. Xin sao. Is that good? Mohabayo. What does that mean? Cheers. Cheers. Nice. In Greek, it's called yamas, which is basically we are saying to our health. So we are healthy. That's basically it. We drink beers too, I guess. What do you drink here? Mohabayo. Okay, I'll take a note of that. Should we continue? Is everyone ready? We'll have a break for lunch in like 30 minutes, so this should be rather quick. No worries. Also, please pay attention because after this module, we'll have a quiz for everybody where everybody will play and we'll see how familiar you are with things so far. Let's see who will be our first quiz winner. At the end of the day, we'll have a second one. But let's see. I think we should get starting. Cool, so what are Sui and Move? I think you already know, but let's go through the bullets. A new layer 1 blockchain, Sui. Built from scratch for scalability and high throughput. We'll dive deep into this by explaining later on the paths based on the objects that we have. As we said that there is a fast path in the concept of Sui that allows you to skip consensus, thus leading to really high throughput numbers. Mr. Labs, one of the main contributors. As some of you could potentially already know, our team, our founders, initially working in Meta, decided to create their own team after leaving their previous company, which would be the creation of Sui after all, right? And what we are talking all about today. Move, a new smart contract programming language. Rust-like syntax. If any of you guys is already familiar with Rust, you will see that when we are writing Move, it would get a familiar feel. It's not the same language, it's not that it's Rust-based, but it's the syntax is really close to it. Originally developed at Meta, now community-driven. Sui Move flavor developed by Mr. Labs, by one of our founders, who was the original creator, Sam Blackshear, right? Let's move forward. why move and Sui, managing assets, Sui and move synergies, and a bit more about move. This is our agenda for this module, and let's dive into it. We are skipping this because we already dove deep into what a blockchain is. So let's now see, let's say, yesterday's blockchain's approach on a simple flow. So what we are seeing here on yesterday's blockchains, not on Sui, how the flow would go. It's basically that all pending transactions, so any interaction with the blockchain itself, would enter the mempool. The mempool, think of it as basically a waiting area before they are confirmed. So the next step would be then that the network runs a consensus mechanism, so a mechanism to confirm that we agree on what's the truth. After this consensus mechanism, they decide the exact order of these transactions after the mempool. So next, the transactions are executed sequentially, one after the other, in the exact order that the consensus decided on the previous step. And finally, the blockchain state is updated one transaction at a time. Let's now see what the pros and the cons of yesterday's blockchain's approach. Transactions ordered upfront, but same data may be accessed by different transactions. What does that mean? Two completely unrelated transactions, me sending Sui to some of you, and another person interacting with a game that exists on Web3, those two would have to be sequenced, but they are unrelated. They have no reason to do that. They could theoretically be parallelized. Is this reliable? Absolutely. This is definitely this is definitely reliable, because you cannot have inconsistent states due to this sequentiality. But is it fast? Not really. As we said, two completely unrelated transactions, not just two, X amount of unrelated transactions, would be batched and wait for the same thing for no absolute reason. And is it cheap? Also not really. Because when the network slows down basically, and the users compete with limited block space, they might have to incentivize the validators by saying, I'll pay more gas if you put my transaction earlier. We know that this is the case for other networks, right? So not cheap as well. Let's see how we in Sui are tackling these issues. Before we do that, let's see yesterday's smart contract languages. What about asset management? Asset management. Assets are second-class citizens. What does that mean? It means that basically your assets will be only able to be accessed through a smart contract. They are not directly under your ownership, but they are under your ownership in the sense that you own them through a smart contract. That's also not the case in Sui. Also, some concerns like the programming simplicity, how intuitive it is to the developer to understand what they're doing, and what about the safety? Let's see a scenario of transferring a token, for example, just a super simple scenario in yesterday's smart contracts, how that would make sense. We see that we have Alice's account, we have Bob's account, and then we have a tokens smart contract, which, as we see here, has a mapping inside of it. Let's see. Alice purchases a token through the smart contract. We see that Alice, now Alice's account inside the tokens array, inside this smart contract, gets the value of 1. So that means that inside this smart contract state, Alice now has 1 token. Great. Now Alice wants to transfer this token probably to Bob's account, right? We see that Alice's account now has a value of 0 in the tokens array, and Bob's account has a value of 1. So, what does this tell us? Alice and Bob don't really own anything. The smart contract does. So, they cannot actually access and own their assets. So, they cannot lend these tokens, store, or have other contracts to use their assets. Another security reason. So, let's say that this smart contract that they were using to create, purchase the tokens and transfer the tokens had an issue and it was exploited or hacked. They would actually lose their assets even though they did not get their private keys compromised. So let's say that I utilize a smart contract that holds the state that I have X amount of tokens. And this smart contract, for example, is hacked. I will lose my assets even though I am not at fault. If I had complete ownership of my assets, I would only lose them if I lost my private keys. So this is a safety concern as well. How about we see how this exact flow will be done in Sui with the idea of object ownership. So we have Alice's account, Bob's account, and a token smart contract. Once again, Alice invokes a purchase function on the token smart contract. We see that an object of type token, right, it's created. This object itself is transferred into Alice's account. So now Alice, in a sense, holds this token. You see here that it's under the Alice account. It does not live inside the state of a smart contract. The smart contract was just used as a program that helped Alice attain this token. After it did its job, it now gave the token to Alice. So what does Alice do? She just transfers this token object to Bob. No smart contract in the middle, basically. So she invokes this function, and now the token just is moved to Bob's account. The owner of this token object, this coin, is now Bob. See that the objects themselves are owned by the addresses, by the wallets, not by the contract. This is the main difference that you will see while working with Move, basically. Alice actually owns an asset. Alice can transfer her asset to Bob directly without token smart contract involvement. Solving the previous security concern that a smart contract could get compromised and they lose their assets. Now they cannot do that because their assets are actually owned by them. Okay, so Move's object composability. I want you to raise your hand if you are already familiar with any object-oriented programming language, like C++, Java, or any object-oriented programming language, in the sense that an object has its properties, an object has its certain capabilities, and so on and so forth. Java, yeah. I started with Java too when I was in university. I like Java. What? PHP. PHP, you said. No, it is not, yeah. You will understand the concept of an object-oriented approach with Move. No worries. I was just trying to make a correlation. Those who, for example, know Java will find this really intuitive, how Move works. So, for example, we see here that this capybara, if I'm not mistaken, this animal here, has some certain properties. This is basically saying that the pattern is a fox, or it's a fox, not a capybara. It has some properties like the charisma, like the emotion, ears. It's of type gen, and this explorer link, and so on and so forth. Let's see what we mean by object composability. So, now that in Move, objects are actually first-class citizens. That means that any NFT, for example, like this animal, would actually have its own ID and live on chain. That meaning it does not live in a smart contract as we saw previously, but you could actually be able to go to an explorer, query for a certain ID, and see this object itself. So, in most other blockchains, assets like this NFT would just be entries inside a table, and they would not exist independently. But in Sui, that's not the case. As we said, every object has its unique identifier. Of course, it has to be a unique identifier to be different from every other asset that exists on chain, and it has its own state. So that means that you can interact with it as a real object, as this coffee that I have here. I can transfer it to somebody, I can pass it, I can utilize it, I can do whatever I wish with it. Because I own it and I hold it. As long as I am the one holding it, I can do whatever with it. It's not that I only utilize it through a smart contract. What about object composability? That means that an object, for example, this NFT, can own other objects. So you can imagine that we can create more complex scenarios where, for example, a hero, as we said, could equip a weapon. So depict more, let's say, interesting business cases in any field through object composability. Like a game character can own multiple item objects, or a vault can own several token objects. This ownership is native and is directly set at the Move level, and we'll see how. Let's see how this mapping of something that lives on Sui is depicted through the Move programming language. On the Sui side, we see we said that each object has a unique ID. Makes sense, it lives on chain, it has to have a unique ID to differ from all the other objects. It can be owned by an account or another object, as we said, with object composability. On the Move side, if there is an object that, if you are setting up a struct, as you see on the right here, if you are setting up a struct, this is a struct definition in Move. For example, a struct of a coin. If you are setting up a struct that will depict an object that will live on chain, you have to set the key ability. You see that has key. While working with Move code at the end of this day and to the days moving forward, we'll explain in detail what these abilities are. There are a few more abilities than you can give a struct, but just for this example here, just know that if you want to say that this struct of type coin, for example, will live on chain, it has to have the key ability. And if it has the key ability, you have to give it an ID field, which will be its unique identifier. As you see here, this coin has a key ability and it has a field of ID and another field of balance. You could put whatever you like. Any questions so far? This is just some basic stuff so you can get the idea of what we'll be doing with move, how we'll be defining structs. Now, about object states. I've mentioned stuff here and there a bit about object states in Sui and Move. They are these 4 different, let's say, states in objects. They are the owned objects. What we said, it's basically, for example, an NFT. It has an owner, a specific owner. So if I was to open my wallet, for example, for this account, and I have 2 capybaras, I would be able to see 2 objects of type capybara with their different fields and stuff under my own ownership, not inside a smart contract. I can see them straight from my wallet. They are the shared objects. We have not talked about shared objects so far. Anyone has any idea what shared objects could be? Take a guess. We have not mentioned it before. You can be wrong, of course. Take a guess. Anyone, you want to take a guess? Yeah, please. Can you pass the microphone, please? Somebody? It's in front of, on the, yeah, thank you.
I think self-judge is about any people also have this object, and this object can be writable and editable or
Correct. It's basically objects that are not owned by anyone. Imagine that a good use case scenario for this would be, for example, some sort of storage or registry, or something that you want everybody to be able to look up and use. This would be an object that, as we will see later, of course, this object, since it's shared, so it can be used by everybody, this type of object needs to pass through consensus. The owned objects do not actually need to pass through consensus. That means that if I am transferring Sui to you, this is an owned object of type coin that I want to transfer to you, does not need to pass through consensus. So this is why we previously showed that we have such a high throughput and such a high number of transactions per second, because of the object-centric model, and because of like almost close to the entirety of transactions on chain is most of them are transactions of owned objects. So if we are not touching a shared object, we can just skip consensus and have a high throughput. If we are touching a shared object, we have to pass through consensus, so we have a consistent state. Immutable, read-only objects and not owned by anyone. We will see that these will be our contracts, which are immutable objects. If you publish a contract, you do not actually own it. You publish it to the network. You could, it does have a publisher field, like who published it, because you would want to guard somehow the access to you if you were the publisher. We'll see how we can do that, but you do not actually own. So we have owned, shared, immutable, and some other, let's say, system objects. Let's now dive deeper, and as, let's say, a final thing for this section of the bootcamp today, I will jump into the final slide, which basically explains the entire flow. This is just step by step, we'll see. I'll go to the final step, which is this, and we'll explain how this is depicted, how the fast path and the less fast path is depicted on Sui. We see that we have two transactions, a transaction by Alice, starting from the left, of course, and a transaction by Bob. So these are two separate transactions. Let's say that Alice is transferring her NFT, and Bob is interacting with a DeFi protocol. So these two transactions may involve different objects. These could be either owned or shared objects. So let's go on step 2. We see consistent broadcast. That means that all transactions are actually broadcast to the validators, and the validators receive them and verify them, basically, as this first step. This is where we also determine what type of objects they are, if they are shared, if they are owned, or so that we know in which path we will guide them. So after we know what type of objects they are, the next question will be, do they need consensus? Let's say they do not. They are the transaction of a known object. So no need for consensus, just we're going to execution and update and certificate sequencing checkpointing, basically finalizing the state of the network with this new transaction added. So this first line would be the fast path, right? Let's now go back into need consensus, this question, and say that it does need consensus because we are touching a shared object. So, in that sense, as usual, the validators now need to agree on an order, since we are touching the shared object. What do we mean by the next step, per object consensus? So, if a transaction touches a shared object, actually, Sui runs a consensus only for those specific objects, not like in traditional blockchains that everything would go through the same ordering. But let's say each shared object has its own mini consensus channel. Think of it like that. So you need consensus for this object, not for the entire network. So even there, less friction. Okay, to the next step, we have another question. Are we touching the same object? If we are not, then after the consensus is done, we can just go ahead and move to execution/update and then finalize the transaction itself. If we are touching the same object, we are actually executing this after the consensus is finalized. So as we said, each shared object has its own mini consensus channel. So if we're touching different objects, we can just go ahead and do that. If we are touching the same object, we need to pass through the consensus. Afterwards, the final step, as we said, step 6 is basically the finalizing of and checkpointing of this transaction. Any questions on this? Is it clear the fact that when we are not touching shared objects, we can just go ahead through the fast path and finalize the transaction really quickly? If we are touching basically a shared object, we need to go through consensus for this specific shared object. Does that make sense? Any questions regarding this? Yes, please, can you get the microphone?
So, why sending coin to another address don't go through consensus? Do you think is this an unsafe way?
Why doesn't it need consensus?
Yeah.
Basically.
How do you make sure that it's secure?
Due to the nature of the architecture, since an object cannot be you can actually only interact and do actions with an object if you own it. That is predefined by the network code. So if you are the owner of an object, you can pass it around, use it, whatever. So if you are no longer the owner of the object, that means that you have transferred it, then you would not be able to actually utilize it. So in that sense, it is safe. So it does not need to pass through consensus, since it's an object between two entities and it's a known object. It's not that everybody needs to know. Everybody needs to. Of course, everybody needs to know. This is depicted on the state of the network. This after this transaction is finalized. But we don't have to think of it as, we don't have to get everybody to agree for me to send money to you, right? I know that I hold this microphone and I just can give it to you. And after I do that, we tell everyone. This is how you can think about it. In yesterday's blockchains, as we said, it would be like, I will ask everybody for permission to give you the microphone. But now that I am holding it, and it's not that the network knows that I have a good analogy for this. Imagine in yesterday's blockchains, we have, let's say, a display of objects, and in this display it says that Dio owns this microphone. So if I want to give it to you, I would be like, guys, do you all agree that I own this microphone and I can give it to my friend? And everybody would be like, yes, you do own it, so you can give it to them. Now, with Sui and the object-centric model, it's not that it's on a display. I hold it, so I have it in my hand. So I don't need to ask anybody. It's of course, it's, how can I say? It's clear that I own it. So I just hand it to you. That's the way to think about it and understand why it's different and why it's safe. So you can only interact with it if you own it.
Okay, what if I run a node, like I become a validator, and I will try my best to edit the data, and then I just, create 10 billion of Sui and then send to others, and I fake it, and then I just say, oh, I just make a transaction and it's safe.
I see what you mean. In order for a transaction actually to go through, I'll go back to slashing before I say that. Think of it that if you were a validator and you're trying to act in a malicious way, you are risking your stake. So, first of all, the amounts of stake would be immense that you would be risking for this. So, the state of the network is not local to and different to every validator. It's basically a unified between the network of validators. So if you were the one that would suggest, let's say, a malicious or a fake transaction or something like that you mentioned, it would be caught by the rest of the network and you would be slashed afterwards, right? You would be penalized. Doesn't mean that any validator can force their own truth in the rest of the network. Did I answer your question?
So you mean that if I try to edit the data, it will ask all the node, and if it detect the fraud, then it will slash my staking?
Yes.
Okay, yes. I got it.
This is why slashing and the penalizing mechanism is important to be set inside the validators. It's agreed upon, this code runs through every validator, and it's automatically detected in a sense.
Okay, makes sense.
Any other questions? Should we move forward? I think we're almost done. We can just a quick overview of the Sui architecture before we go to the quiz and the lunch break. Just a quick recap of what we said previously, for example, with the full node. On the left, we have the user, which interacts with Sui, for example, through a web app or through a smartphone application. Either or. It's just an application that utilizes Web3 and specifically Sui. Then the next step would be speaking to the full node, which the full node basically keeps a copy of the state of the chain, and let's say, as we previously mentioned, acts as a gateway between the application and the validators. See that this is the intermediate step, the full node, from the user to the validators. Just a recap, the full node does not create blocks or participate in the consensus. That's the validator's job. It's just your gateway to the validators. I think that's pretty much it for this presentation too. If you have no further questions, I would like to test your knowledge so far in a fun and interactive way by a quiz. And how we will do that is basically I will pull up a QR code here and you guys will join the quiz, add your nicknames or whatever you prefer, and let's see if we did a good job so far. And I'm talking about me, if I did a good job explaining things, because if I did, I'm sure you guys will have caught everything. Any questions? Should we move forward to the quiz? Good? Let's do it. This is the Telegram chat. I'll leave it here. It's not this one. I'll give you a QR code for the quiz now. Yeah, I will send it on Telegram too. I will pull the QR code there and I will send the link to Telegram as well. Whatever you guys prefer. Let's go. We'll wait for everybody to join the quiz. Let's make gamify the lesson today. You'll see that the questions are pretty straightforward. Yeah, of course. We'll wait till this number reaches 22. I think we are 22 here, 22 students. So we'll wait for everybody to join. Is anyone who wants to join and hasn't already? I see 21. Are we all ready? Should I start? If you do not see the screen so much, because text will appear, questions and answers, look at your screens, right? You will see at your screens, either your phones or your laptops, wherever you joined from, you will see the answers. So make sure you read the answers correctly. Should we get started? Ready? Okay, let's start. Did I hear someone say wait? Should I start this? I am starting. Let's go. Good luck to everyone. What is the key difference between Web 2 and Web 3? We have no music. No. H. Lamb with the first place alongside Bernie. Okay, most of you got this. Only one answered wrong. Of course, Web3 gives users total control through personal wallets. What is a smart contract? You guys are experts. I don't know why I'm here. Come on. You're so good. Let's go on to the next one. I like that you take your time and you read the answers correctly. Okay, we have different answers on this one. H. Lamb still on the lead. Who is H. Lamb? Who is? Oh, you are. Good job. You're still in the lead. Let's see the correct answer for this one, though. What are some of the benefits? Some of the benefits. So this was a multi-select question. Increased transparency, elimination of intermediaries in financial transactions, and immediate settlement. How Sui binds a transaction to a specific account. Remember the example with Alice and Bob. Good job, everyone. Almost everyone has gotten this correct. The transaction is signed with the user's private key. What is SUINS? If you think this stuff is really easy, answer fast for more points. The faster you answer, the more points you get for this one. Or not for this one, for any question. It's a really only 10-point difference between first place and second place. Really tight maths. Let's see. Let's see. We did not get into this. Let me see your guesses. Which are valid Sui-ness names? Multi-selection. Oh, we have a different William at the first place. So let's see the correct answer. Indeed, my name Sui
Buổi này chiều record tiếp nha anh em ơi.
are both valid Sui-ness names.